Hi, we're talking about similar triangles. Similar triangles are two triangles that have the same angles, right? They do not have to have the same side length. If a triangle happens to have the same angles and the same side length, then they're going to be congruent. If two triangles have the same side length alone, well, then it has to be congruent to the other triangle because the angles have to be the same. Right? What we're talking about today is two triangles that only have the angles that are the same. Right now, in order to definitively show and conclude that triangles are similar, the only thing that has to be known is that two angles of one triangle are congruent, the same, equal, to two angles of another triangle. Right? Because the fact that all triangles and every single triangle, all the angles add up to 180 degrees, that means that if these two angles maybe add up to 100 because they're the same, that means these two angles add up to 100 because they're the same, right? And since they all have to sum up to 180 in each triangle, that means these angles have to be 80, for instance. So we're going to use congruent markings like A with arc and a slash, and D with an arc and a slash to show that A and D are the same value. A and D are congruent angles. Angle C, angle F in this example are also the same measure. So since we know that one angle or two angles of one triangle are congruent to two angles of another, this is where we can determine that triangle ABC is similar to triangle DEF. And the way we're writing this down, we are lining up A and D, B and E, and we are lining up C and F because those are called the corresponding angles. Those are the corresponding angles that are congruent to one another. And because these angles are the same, that means these triangles are similar, right? This is the similarity symbol right here. And because these triangles are similar, if we label the sides of these triangles to be lowercase a, b, and c, which is a very normal naming scheme and one that we will follow in class, these triangles will be named by their vertices, by their angles, which are capital A, B, and C, and their sides will be named with the same letters, but lowercase. And you can identify the lowercase, you can identify the side that corresponds to an angle because it will be across the triangle from that angle. Side D is located across from angle D. On the bottom, because angle E is up top, that means the side E is on bottom, across from it. And then F is over on the left side because angle F is on the right side. Right, so if we look at is there a relationship we know that the angles are the same, but is there a relationship between the sides? And the answer is yes. The side on the right side, A, corresponds to the side on the right side, D. Right? They're not the same, but they do have a relationship because the ratio of A to D is the same as the ratio of B to E. And what that means is that, let's say if D is twice as long as A, that means E also has to be twice as long as B, right? That's what it means when things are proportional. That means they have the same basic factors, right? They have their relationship between the sides are the same. Not that the measures are the same, but they're the same in the same size difference, right? So side C and side F are going to correspond to one another. Again, they're not going to be the same, but they're going to differ by the same way that A and D differ, by the same way that B and E differ, right? By a common factor. So this is a proportion. A proportion normally has two fractions, two ratios on each side. I'm showing all three because, again, you do have that option. But when you're writing out your own proportion, you're only writing out two of the three proportional sides. All right, let's look at an example. Number one here, triangle 1 is triangle PQR, has a side length of 10 over here and a side length over here of unknown Q. XYZ is the larger triangle, side length of 7, bottom side length of 19. And we can see that angle P and angle Y are the same. Angle Q and angle X are the same. That allows us to conclude that these triangles are similar. And that means that we can solve for Q by writing a proportion 10 over Q, which is this side over that side, is equal to 7 over 19, which is the same two corresponding sides on the other triangle. Right? Writing out a proportion is about being consistent. Right? If I were to look at the left side of each of these triangles, 10 over 7, then I could write a ratio of Q over 19 because I am being consistent in which side I am writing first and from which triangle I am writing first. Right? If you take a look at these two examples, the top over here, 10 and 7, both kind of are the same side of each triangle, right? The left side, if you will. And if you look at Q and 19, these are both the bottom side, right? Those are both the values, Q and 19, that represent the bottom side. And if we were to look at this vertically, we would see that 10 over Q comes from triangle 1, and 7 over 19 comes from triangle 2. Now let's look at the other proportion. Were we also consistent when we were writing out this proportion? 10 and Q are going to come from triangle 1. 7 and 19 are going to come from triangle 2. 10 over 7 represents the left side, and Q over 19 represents the bottom side. Now, which way is correct to write this proportion? The answer is they're both correct, and they're both equally correct because they will both result in the same answer. We're going to take this 10 over Q equals 7 over 19, and we're going to cross multiply, which means that we're going to multiply the diagonal values. 7 times Q equals 10 times 19. And then the result is an equation that we can solve by multiplying those values, dividing by 7 on both sides. This is a Q, by the way. And Q is equal to a fraction of 190 over 7. Let's look at another example. All right, this one is a little bit trickier because, again, it's important to be able to match up the corresponding angles, the angles that are congruent to one another, so that you can match up the sides that are corresponding to one another. This angle has one slash, which means that when we write out our triangle 2, right, if we look at the way it's given to us, it's not given to us with the one slash angle down on the lower left-hand side. So let's, in our minds, turn it so that it does do that, right? What you're doing here is, I have the liberty because I am using an iPad. What you want to do is literally just turn this triangle like this, right? And if that means turning your paper, then so be it. That's great. If it's on a computer, like a computer screen, you can't really turn it, then the next best thing we're going to do is try to redraw triangle 2, okay? Put down the slash marks first where you want them. Again, one on the lower left, the double on the lower right. And take a look, this one slash mark has the letter R attached to it. And this 2 slash mark has the letter Q attached to it. And up here has no slashes, that's the letter P. Side length of 2 is for QR, so that's down here. Side length of 3 is for PR, so that's over here. And now we can kind of disregard this triangle because this is the one that is going to be in the same orientation as our triangle 1. And we could write a proportion based on this, right? We can write down 5 over 3x plus 15 is equal to 3 over 2. We can write out 5 over 3 is equal to 3x plus 15 over 2, right? If we want to start with the smaller triangle up top and write out like 3 over 2 equals 5 over 3x plus 15, that's totally fine, right? That's the same thing as this, just switched around. So there are multiple ways to write out a correct proportion. As long as you are consistent, then you should be fine. So let's take one of these and cross multiply these values to get 3 times 3x plus 5 equals 5 times 2. Distribute our 3 to get 9x plus 15 equals 10. Subtract 5, 9x is equal to negative 5. Divide by 9 and we get an answer of x equaling negative 5 over 9. And that's all for similar triangles and proportions.